All right, welcome to video number 2. So video number 2 will be about the 40-yard dash activity. But first, let me pull up the other activity that I want to go over. So, um, so this is that second activity, so the levels activity. But so this all gets over starting here from what we started on this activity. And so what we actually did then is actually ran, and I don't have that video, and I don't really want to play that video as well. But so having technical difficulties playing the video. But this is what we kind of started off with. So I don't know what we have here, but we started off with that 40-yard dash. So what we did is then we answered all these different questions, right? How far do you go in 20 yards? And again, that was actually a little bit confusing question for students, but of trying to find these different times and finding how far you win in these different times. But again, it's always try to get the slope, and so we want the slope per 1 second. Okay, so because again, right now we know for Julio Jones, just so we'll go on Julio Jones, is that Julio Jones went 40 yards in 4.39 seconds. Well, so we know he goes 80 yards, right, in 8 point, just double that, so that's 78 seconds, okay? So we know that, but that doesn't do us much good, right, because it's not a unit rate. In this case, it's not the slope. It is a slope, but it's not the slope because the slope is always per 1. And so we want this for 1 second, and you could divide each one of those, right, 40 divided by 4.39. Or if you want to even do the other one that's scaled up, because slope will always give you the same value, is 8.78, and you're always going to get this 9.11 yards for 1 second. And this is a lot more useful, okay? 9.11 yards for every 1 second. And now we can know as well, how much did he run in 1 second? How much did he run in 2 seconds, and 3 seconds, and 4 seconds? And you can actually see in 4 seconds, he'll be really close to 40 yards, because in 4.39 seconds, he's at 40 yards. But we want to do that. So now, then what we did to make it a little bit harder is, right, if he gets a head start, right? So let's say if he gets a 15-yard head start, well, then we want to see what? Well, let's say if it's in 60 seconds. So he's going to be going 9.11 yards per second, so 9.11. And again, I apologize for I can actually kind of open a new window here. So I'll just open a new window, and I don't know if actually that will work being here. So let's actually make up a new smart notebook window to see that. So I apologize for taking a little bit here. But we want to find that 9.11 yards per second. So it's all the way over here. All right. So we have that 9.11 times the 60 seconds, but then we have to add in that 15-yard head start. All right, so that'll tell us how far he's gone in this 1 second. And again, and that's what it's useful of finding that per 1 second. Finding the unit rate per every 1 second. So that's why we had that 9.11 yards per second. Okay, so that's we times it by however many seconds it is. So let's say if we wanted 80 seconds, well, we take 9.11 times 80 seconds plus that 15-yard head start. Okay, to find that. And again, if you want to say what our equation is for this case, if it's a 15-yard head start, and again, on your homework, it's a different head start, I believe. So an 80-yard head start. So just trying to find out where we are in those different times. And actually, number 5, maybe a little typo there of a 200-yard race, because after 50 seconds, after 50 seconds, you may actually finish. So times 10. Yeah, you're actually going to have already finished the race. So on that. So, but again, trying to get sidetracked at number 5 there, but 9.11 times whatever our seconds is. So let's just say that's x plus 15. will always give us our y, which in this case is our total distance. So again, don't forget how to find your slope, right? We take 40 divided by the second, so in this case 4.39. And then once we have our slope, which is 9.11, then we multiply it, right? We multiply our slope by this, and then don't forget to add our y-intercept, again, our start value. Just like the marble problem had a start value, this had a start value. So then after we did this, what we did is, okay, we've had a lot of problems with context, now let's go without context, all right? And so that's what these levels were. Okay, so we did these level problems, right? So we have A, B, C, D, and so the whole goal was to kind of test and see where we are. And again, we want to improve that. So so we had A, so again, scaling up, and also tried to create an equation. So it decreases. And actually, let's just even, well, yeah, that could be on some of those different problems. But and actually, let me see if these are actually the same or not for your homework. So these different questions, yes, actually it's different than your homework. I think this is actually the same stuff you're going to get for your exit slip on this week. So if you watch this, we already kind of go through these ones in the exit slip. But is again, how do we multiply this out, and how do we get this equation? And actually, we had a really good pattern that somebody made that I put on a do now, which is, again, which I always try to do, is share good ideas using that do now. I think it's this one. If it would come up. Okay, there we go. Yeah, so this one even really shows it, right, of seeing what this equation is that we're growing more and more 2's, right? So the rate of change, so now we're not using numbers, but this is just really showing that the rate of change is 2, right? We have 1, 2, okay? 1, 2. And then we have, let's say even like this one, is 4 2's, right? So this is 4 2's. And then how many 5's are we adding? 1. 1 5, 1 5, 1 5. And so in this case, our equation, in this, if you want to look at this one, this is 0 2's plus 5. And so our equation is, the 2 is always multiplying, it's 2 times x plus 5. You see that we're always multiplying by 2, and then we're always adding 5. And then y, this value, because it also changes, right, this value is always equal to that. So it's y equals 2x plus 5. So we looked at that pattern, and we saw that, and so again, you're not just adding 1 2, you're adding 1 more 2. And so again, if you want to look at like 50 times 2, well, there's 50 2's. But does it make sense to write 2 50 times? No, right? But, and again, there is still only 1 5, because again, that's what we started at when that x is equal to 0. And if you remember those videos, again, 0 is that special value because it represents nothing. And that's where we start our pattern. So it's y equals 2x plus 5. So using that to help us explain the other problems. So let's find that. Back to our problems. If I can find it, it goes back. That's our yard dash. So using this, you see that we're adding more and more 6's. So it's 3 6's, 2 6's, 1 6. And so this is y equals -6 times x, because that x, this x value, tells us how many 6's. And so for 33, it'd be 33 times -6. This is the whole thing. I'm sorry, 33 times. I use a dot instead of an x because it gets a little bit confusing, that an x variable, right, with multiplication. So make sure you do that. Then what we do is we switch gears. Now we have that start value again. So it's still 7 is 5 plus 2. 17 is 5 times 2 plus 2. I'm sorry, 12 is. Then 17 is 5 times 3 plus 2. So you see that pattern. We always multiply by our slope. In this case, our slope is 5. And so our equation here is y equals 5x plus 2. Now, what happens when the slope is not as difficult? Now again, make sure you know, well, first off, even looking at level D, now our slope is going down, right? So you can think of this as y equals -4x plus 6. All right, so that's a negative. Once it goes down, like this one, level B and level D goes down, then our slope is negative. Okay, when it goes up or it increases, our slope is positive. So that's make sure you know what those start values. Okay, I'm sorry, those slopes of how do you still put it? You still use multiplication, but when it goes down, you just multiply by a negative number, not a positive number. Now, what we did also on a do now that's most recent is how do we find the slope when it's not as difficult? And what we did is we used just the same thing what we did with the marble problem. So if you didn't watch the first video, I would suggest go back and watch the first video so you can get the help on the marble problem. But again, let's pull up that do now we showed slope on. So that one was this one. Okay, so it actually is actually it's not on this one, darn. So it's 10.7. It was this one, right on the bottom here. So this one, and no, maybe view. So how did a person find the slope when it's not given? And so what we saw on this one is that, what do we do? Well, what we first do is we subtract the x's and subtract the y's. So I'll do this harder one right here, right? And so this is actually 26 minus 14, just a typo here. But we subtract the y's and subtract the x's. And this is just, and again, make sure you don't go left to right, right? That is not what you do. Don't do that, right? Don't go, you always go up and down, the x's with the x's, the y's with the y's. And so you subtract 29 minus 4, you get 25. And you subtract 8 minus 3, you get 5. Okay, and so that's what they did up here as well, right? You subtracted that, subtracted the 0 and the 4. So you subtract, and then you want it per 1. And so we take that just like we wanted it, what we had last time was 50 grams, right? We subtracted and we got it for 10 marbles. Well, we want it for 1 marble, so we divided. So now we wanted 25 y's, this is a y, for 5 x's. And so we wanted 1 x, and so you take 25 divided by 5, and you get 5. And so in this case, our slope is 5. And if you expand that pattern, right, so 3, and you actually go all the way to 8, 5, 6, 7, 8, you can actually show that 5 is the slope. And now that you know the slope, you can find that other value. So 3 is at 4, and if you add 5, so you get 9, 14, 19, 24, and then sure enough we get 29, which is what 8 should be, right? 8 should be at 29 if you actually went by 5. So now we have our rate of change of 5. Now to find our start value, we just have to scale up. So 2 is negative 1, 1 is going 5 is negative 6, and then 0 is negative 11. And so that's our start value as well. And we'll go into another way of how do we find the start value as well, but the bell's about to ring, so make sure you just look in your notes. We'll put the other way to find the start value in the notes. But now we have our start value. So again, when you don't know what your slope is, you subtract. That's the first step. And again, this is in your notes. Then after you subtract, then you divide. And if you want to, if you have time, check to see it does the slope work. So in this case, sure enough, if you add by 5, the slope does work. All right. Again, watch this video multiple times. And if you have questions, please let me know. Thank you so much, and I hope this helps. And make sure you turn those projects in. Thank you. Thank you.